y'all doing? I know it's like summertime. For those of you that are watching this after you took this, I do have to sincerely apologize. I have no idea why New York State made us wait so long. I've been dying to get these answers out to you. So, again, my name is Mr. Krause. You can call me Mr. Key. And let's just get started because I know you're anxious to get started. If you haven't hit the subscribe button, hit the subscribe button. You know, there's some chances that my Miss Newman and I are going to be doing AP statistics and SAT prep, or maybe a combination. She also teaches calculus, so that's in the air for the future as well. But anyway, today we're going to be doing part 1, questions 13 through 24. And all of this can be found at www.nkinfinity.com. All right, so if you can't find the other ones, just go there. You can always search Kendrick Krause on YouTube and check my channel out. But if you hit subscribe, that's the easiest way to find us. So let's get going. Let's get rocking and rolling. Question 13. A student studying a public policy created a model for the population of Detroit where the population decreased by 25% over a decade. So I haven't seen one like this one. This is kind of tricky. We're decreasing over a decade. That means in 10 years, it's going down by 25%. All right, so hence this formula P just P, I guess. Just using P. That's just P. So P is equal to 714.75 to the D. Now, what we want this to be in terms of years. Y in terms of years. Okay, so let's think about this. Let's say we had 10 years. Well, that would equal 1 decade. 10 years. So if I just put Y here, then that would mean that we would be going down by 25% every year, right? But it takes 10 years to go down 1. So what I want to do is I want to take this and I want to multiply by 1/10. So it's 1/10. So now look what happens when Y is 10. 10 times 1/10 is 1, which takes us back to this formula if I plug a 1 in. So that was the trick right there. You had to take the number of years and divide by 10. Number of years and divide by 10. Now, the other thing I also said to you is this. I said to you when we're doing half-life formulas, doubling life formulas, blah, blah, it's every. Well, it's decreasing 25% every 10 years. And I said you always divide by the every. So you could have written this as Y over 10. So we'll just select that one. Oh, crap. They don't have it. So what we're going to do now, and this is what New York State, and this comes up every freaking time, and I don't know why, 0.75, and this 1/10 times Y, what they're doing is they're putting that 1/10 in there. And if you raise 0.75, I think it's 0.97, 0.75 raised to I'm just going to use 0.1 because that's the same as 1/10. You get 0.9716. So the answer is this one. The 1/10 comes inside. Tricky question. And then you go to an easy question. The probability that Gary and Jane have a child with blue eyes is 0.25, and the probability they have a child with blonde hair is 0.5. The probability they have a child with both blue eyes and blonde hair. So the probability of blue eyes is equal to 0.25. The probability of blonde hair is equal to 0.5. And the probability of blue eyes and blonde hair, not blue hair, is 0.125. Now, if they were mutually exclusive, the probability of your AND event would be equal to 0. If they were mutually exclusive. So 3 can't work. So anything with 3 can't work. So now we're down to, is it independent or is it dependent? Now the test for independence is the probability of A and B is equal to the probability of A times the probability of B. We studied this a lot. So the probability of A times B If it equals 0.125, then they're independent. If it does not equal 0.125, then they're dependent. And since 0.5 times 0.25 is 0.15, they are in fact independent. They are in fact independent, so it should be choice 2 only. 14 is choice 2. Yes. There we go. Wow, is this a reading question? Based on the climate Bar Harbor, Maine. So Bar Harbor, Maine, let me highlight these for you because it's, so Bar Harbor will be yellow. And then I'll do the other one in blue. Phoenix will be in blue. And so what I'm going to do down here is every time I see Phoenix, I'm going to do that. And then every time I see Bar Harbor, I'm going to do that in yellow. Okay, and then I missed the Phoenix. So let's see what's going on. So remember, these are our amplitudes. These are the swings up and down. Remember, amplitude on a sine curve is how much up it goes and how far down it goes. So the amplitude on Bar Harbor is up 23.9, down 23.9. On Phoenix, it's up 20.2 and down 20.2. All right, so let's do it. Now, again, thank you, New York State. Here's the word not. Which statement cannot be concluded based on the average monthly temperature in X months? So let's see which one cannot be. The average monthly temperature variation, how much it goes up and how much it goes down, is more for Bar Harbor. Well, the variation here is 23 up and 23 down. The variation here is 20 up and 20 down. So that's not it. That's true. Excuse me. That's true, so that's not it. Woo! New York State. The midline average monthly temperature. Okay, let's think about midline. Here's the midline for this one and the midline for this one. So the midline temperature for Bar Harbor is lower than the midline temperature for Phoenix. Yes, that's true. The maximum average temperature for Bar Harbor. Now remember, to find max, it's midline plus amplitude. So I take this and I add this. So what's 55 and 23? That's 78, about 79. That looks like it's right. The minimum average monthly temperature for Phoenix. Now minimum is midline minus amplitude. I'm sorry if that's behind my head. It says midline minus amplitude. So my midline here is 86, and I'm going to subtract 20. It's around 66. It sure the heck isn't 20. So that's that answer. All right, let's move on. Which expressions are equivalent to 1 divided by the 6th root of x? Well, 1 divided by the 6th root of x. That's what they're asking about. So there's a couple of different ways to do this. I'm going to show you the math way to do it, and then I'm going to show you the other way to do it. So you should know that anytime you have this, roots are the denominators of a rational function. So this can be written as x to the 1/6 power. X to the 1/6 power, because these two things mean the same exact stuff. So since this is on the denominator, if I bring it to the numerator, remember it gets a sign change. So this is really x to the negative 1/6. So choice 3 works. So 3 works. So it can't be this one. Now, okay, now let's look and see what this is. This is really x to the 1/6. Now if that's x to the 1/6, this is x to the 1/3. Well, that means these two things are exactly the same. And since 3 works, and these two things are exactly the same, it has to be choice 4. But let me show you why. Let's take a look at choice 2. X to the 1/6 over x to the 1/3. Remember, when the bases are same, you subtract the exponent. So we're going to take 1/6 and we're going to subtract off 1/3. But 1/6 minus 1/3 is really 2 sixths. So 1/6 minus 2/6 is negative 1/6. So this whole thing becomes x to the negative 1/6, which is the same as this. So they're all the same, choice 1. Now, how could I have done it differently? I could have done this. Let's just see what's in x. Nope, we don't want that. So 2.56, something stupid, store it in x. And then I just typed them in. Well, I got to go back to my original, which is control division 1 over the 6th root of x. And then just type in all the answers and make sure you get that. But choice 1, 2, and 3 would all work. So because this is a teaching tool, I'm going to show you a couple things on how to eliminate some choices. First things first, you might as well graph this thing, right? Your directrix is y equals negative 2. Your focus is 1, 2. Well, if that's true, then your vertex is 0, 1, 0. Now, all of these are in vertex form. But remember, when the x value goes in, it goes in with opposite signs. So since this is a positive 1, I know it has to be x minus 1. That means it can't be one of these choices. It has to be one of these two. And then the 0 at the end, that's no surprise. There's no number there. So which is it? Well, we've never done one where there was an 8 there, but let's just say it was an 8. Let's use our brain. Let's just say it was an 8. Wouldn't that be going up so steeply? It would be so incredibly steep. Do you think the distance between that, how about the distance between that point and there would be the same? No way in heck. No way in heck. So just using our brain, that's the right answer. Now, how can I verify that on my calculator? Very simply, just go over to my calculator, go into graphing mode. I can't remember if these are turned off for test prep mode or not. I don't remember what gets turned off and what gets turned on. We have a group of individuals that do that. So we go menu. I think it's still available, but I don't remember. Hopefully it is. So get to my calculator. I'm going to type this thing in. 1 divided by 8 parenthesis x minus 1 parentheses squared. There it is. Now I go menu, analyze graph, analyze conics, focus, click on it. There it is, 1, 2. Go to menu, analyze graph, analyze conics, axis of symmetry, click on it. Oops, axis of symmetry is not what I want. Menu, analyze graph, directrix. And I click on it, and there it is, y equals negative 2. So I can do it that way as well. That's a quick check. All right. This question. Shame, shame, shame on you, New York. Or, actually, it's not a bad question. It's just difficult. It's difficult because it is a reading question. Did you read it correctly? So, here's the deal. I'm going to do it in red because it made me a little angry to read this question. Here's my function. P of t is equal. Now, this is my starting amount, right, in 2010. Starting amount. The model's t years as of today, considering the following two statements. As of today, this is the thing that was hard. As of today. Well, today is 6/2017. It is June. It's the very end of June because New York State made us wait. Shame on you. It is the end of June 2007. Do we think that the current population today is going to be the same as it was in 2010, which was our starting amount? So it was kind of tricky. You had to realize that. So it's not 1. So anything with 1 in it doesn't work. So these two don't make sense. So I got to see if I have to see if it's got a 3.9%. Now, this looks like it's a 3.9% growth, but is that really a growth factor? Do I know for sure that that is a growth factor? I think it is. I'm pretty sure it is. And it would be 3.2% by moving the decimal over 3.9% approximately. So let's just see. So I'm going to go to my calculator. I'm going to say, okay, go into calculator mode. I'm going to do 110 e to the 0.03922. And I'm just going to put in 114. Well, let's see if that's a 3% growth. Let's do 110 times 0.03922. Oh, wait. 1 point. It's about a 3.9% growth. There it is. It's approximately. So yes, there's the answer. All right, kids. This is also not a great question. So the question asks if there's an extraneous solution. Clearly, if 2 comes up, that would be an extraneous solution because that would make this 0. Clearly, if 0 comes up as a solution, that would make both of these 0. And that would be an extraneous solution. So I actually have to solve this to see. Now, I'm going to do it the hard way, and I'm going to do it the easy way. The hard way is to actually do the math. So 2x over x minus 2. I don't like that minus, so I'm going to make it up here. You know I hate minuses. X and 8 over x times x minus 2. So what they said was Ren multiplied both sides by the lowest common denominator, which is another way to solve these. You multiply both sides by the lowest common denominator. Now I got to distribute. So when I distribute that to here, the x minus 2's cancel, and I end up with 2x squared. When I multiply it by here, the x's cancel, and I end up with minus 11 x minus 2. And on this side, the whole thing cancels, and I end up with just 8. So let's clean this up. I get 2x squared minus 11x plus 22 equals 8. I'll bring the 8 over. I get 2x squared minus 11x plus 14 equals 0. I believe this factors. 2x and x. I think it's x minus 2 here and 7 here. So these both have to be negative. So that would be 4x and 7x, so that works. So my two answers are x equals 2 and x equals 7 over 2. Now again, if I had ended up with 0 as a solution, 0 would be an extraneous solution too, but I did not. But 2 I ended up with, and 2 cannot be here. Oh, this is actually the answer. 2 can actually not be here because it makes the fraction undefined. But I didn't know, well, I guess it wouldn't have been this one. Actually, they told us what the other solution is here. It wouldn't have been this one. The only two it could be is these. Or, actually, it could be any one of these three. You know, if I had ended up with, let's say, 2.3, then I'd have no extraneous solutions. So just because they're undefined at those points doesn't make them extraneous solutions. It makes them possible extraneous solutions, but not actual extraneous solutions. I know somebody else online did that problem, and he didn't actually explain that correctly. So that's not right. All right, let me take a little break. I'll be right back. All right, let's see what we got here. Yeah. Well, what they're telling us on this problem is that f of 9 is negative 2. So I guess I might want to start with that and see which one I can plug 9 into. So I might go to my calculator and say, okay, we're going to take 9. We'll store it into x. And we'll type these answers in. Negative 8 plus 0.75x. I used x. I used t. No, that's not going to work. Let's try this one. Negative 8 minus 0.75 parenthesis x minus 1. Negative 14. No, that's not going to work. So let's do, what's the next one? Negative 8.75 plus 0.75x. Ooh, -2. That one works. Now let's just check the last one. Don't just stop on 1 just because it works, man. You got to be careful. Plus 8 parenthesis x minus 1. And then parenthesis. So it clearly looks as if this is the answer. If I plugged in 1, if I plugged in n equals to 1, I would have to do negative 0.8. Negative 8.75 plus 0.75 times 1. So that would just be adding 0.75, which would give me -8. And then if you check the other ones, they simply just don't work. And I could try n equals 2 and n equals 3. But clearly this is really all I had to check. Okay, so this was an interesting question. If you tried to use the calculators, because I think most calculators are set up in degree mode, you'd have a problem because this is in radians. So you have to be very, very careful. So let's see here. If I'm going to go into my graphing calculator, first thing I'm going to do is just try to graph this thing. I don't like the fact I got things open. So let me just graph it. And I believe it was 2 raised to the negative 0.25x. Get out of exponent mode times the sine of, I believe it was pi over 2x. Some funky graph looking like this. Okay, so there's a couple of ways to do it. You can go right into the table right now, Control T, and you can go up to -7. There's -7. You get 3.36. Now you had to remember that rate of change is of course the same as slope. So we're going to do the change in y's over the change in x's. Well, the x's are pretty easy. So I'm doing -7 first, and I'm going to subtract 7. And so what's the -7 value? 3.363 minus -0.2973. -0.2973. So I'll put that in my calculator. And I'll go control division. 3.63, minus parentheses, -0.2973 all over -7 minus 7. And you get -2.28. Well, that means that would be close. Now, it's probably not exact because I rounded too much. I rounded a lot. Actually, that number I don't think is right. Hold on. I thought it was 363. It's 363. That's why. That's why. 363. There it is. -0.26. Okay, so I put it in there wrong. 363. But in order to avoid that, by the way, I was not in radian mode. I just checked it. I just put it in there, but I should have showed you what I did. Go to document settings. I was in degree mode. And then I said, oh, wait a second, I need to be in radian mode. So I click on that, go into document settings, choose on radian mode, and I would just choose OK. I wouldn't choose make default. That's a problem. And one other thing I can do is, because I have f of 1 stored, that I could actually do this, control division. Something new you could try. f1 of, I got to do this, -7 parenthesis minus f1 of 7 all over -7 minus 7. And you could do it that way as well and get the same answer. There it is, choice 2. Tough problem if you were in degree mode. Sorry about that. Mallory wants to buy a new Windows for air conditioning unit. The cost for each unit is $329.99. If she plans to run the unit for 3 months out of the year for an annual operating cost of that. All right, so we got to be careful here. Annual operating cost is $108 per year. Which function models the cost per year over a lifetime of the unit. In terms of the number of years, N, that shows the air conditioning. So the cost for the unit is $329. So cost for the unit, so C of N, is equal to $329.99. If she plans to run the unit for 3 months out of the year, for an annual, see, that doesn't make any, that's tricky. That's trying to tricky. That's trying to get you to multiply that thing by 3, and we don't have to. She's only going to run it for 3 months, but the annual operating cost is still $108. So we're going to add $108.78 for N years. Okay, so that's the total cost of the, man, this problem was brutal. This problem was a lot of tricky reading here, kids. See, first of all, you had to understand that 3 months was meaningless. 3 months out of the year, but it still was an annual cost of $108. So this was totally superfluous crap information that we didn't need. And then which function models the cost per year for N years? See, that's kind of tricky too. This is the cost total for N years. So if I want it per year, I have to divide by the number of years and divide by N. And so that makes this problem, this is the answer. Gosh, that was a tricky question right there. Boy, that was brutal. This one you could have just tried some values, but let's see if we got here. I think this numerator's factorable. I'm going to factor the denominator. I'm going to take an x squared out of the denominator. I'm left with x plus 2. And then I'm going to, this is bad. I don't like having a negative here, so I'm going to do negative 3x squared plus 5x minus 2. So I'll factor that sucker. I'm going to show you another way to do this one. 3x and x. I'm guessing it's x plus 2. X plus 2 and then minus 1. That'd be positive 6 and negative 1, which would be positive 5. Okay, so these cancel. So I end up with negative 3x minus 1 over x squared. If I distribute this negative, I get, wow. Wow, that was, so it's really negative 3x plus 1 over x squared, which is not this one. So what they then did, man, New York, thank you very much on this one. Negative 3x over x squared plus 1 over x squared. Well, over x squared. This x cancels with one of these. So this is negative 3 over x, or negative 3x to the negative 1. And this is just plus x to the negative 2. So here's the right answer. Now what I would have done is I would have stowed a number in for x, type these in, type this in, and you'll see that they verify and they match. Man. Woo! Last multiple choice, kids. We're almost done. Jasmine decides to put $100 in a savings account. Here it is, each month. Another tricky question. The account pays 3% annual interest rate, compounded monthly. How much money S will Jasmine have in 1 year? So because it's an annual interest rate, but it's compounded monthly, we don't want to use 0.03. So anything that's got 0.03 in it's got to go. Now, this would be how much money she would have if she just put in $100 and put nothing else in, right, after 12 months. That's what this one will be. But that's not what's going on. We want the summation of all of those, not just one. See, if I did this, this isn't the right way to do it. I want to use this summation formula where I want to add them over and over again. And that we want to use this summation formula. So 24, this is the right answer for this one. Again, 0.03 divided by 12, if you take that on your calculator, 0.03 divided by 12, that gives you your 0.025. And it's 1.025 because it's growth. All right, kids, that's the end of that one. There were some really hard questions on those multiple choice. Luckily for us, the rest of the test wasn't too bad, but the multiple choice were very tricky.